Just like we have exponent properties, we have log properties. So to review your exponent rules, if you have the same base, so you have x to the 4th times x to the 3rd, we add those together to get x to the 7th. So when we multiply, we can remember that we're adding. If you are dividing, we are going to subtract. So here we would 4 minus 3. So when we are dividing, we subtract. And lastly, if we have an exponent being raised to an exponent, we can multiply these and we get x to the 12th. So when you have a power or an exponent being raised to an exponent, power to a power, we multiply. So since exponents and logs are the same thing, just written differently, we are going to have very, very, very similar rules for logs. So the first rule has to do with product, or remember, multiplying. So just like when we're doing exponents, if we are multiplying, we can split this log into 2 logs using addition. And then the first one will be of x, the second will be of y. Quotient rule means dividing. So if you're dividing, then you can turn this into subtraction. So log base b of x, which is the top numerator there of the fraction, minus log base b of the bottom, which is y. Now the power rule, just like exponents, we are going to use, oh, I wrote this. Okay. We are going to change this to multiplying. So what we do to do multiplying is we take this 2 and we actually bring it out front, and instead of an exponent, we say, hey, this is 2 being multiplied by the log. Now you can combine these rules together. When you do that exponent rule, though, it would only apply to the base in which it is touching in the original form. And if you are expanding, which means using these rules to write out one log as multiple logs, you should have no exponents in your final answer. All right, so here we have log base 10 of 7 multiplied by x. So we're going to turn this into 2 logs, one for each one of those parts, log base 10 of 7. Because it is addition, because it's multiplication, it turns into addition, plus log base 10 of 7. The base is going to stay the same. We're just splitting up what we're finding the log of. So here's one log base 4, and we have division. So that division is going to turn into subtraction. So we have log base 4 of 9 minus log base 4 of y. We are splitting the log from 1 log into 2. And then lastly, we have that exponent. We're not allowed to have that in our final answer for expanding. So we're taking that 2, and it's going to come out front, and it's turning into multiplication. 2 multiplied by log base 6m. So let me show you one where we have more than one rule that we're using. If we look down here at number 4, we can see that we're taking the log of 3 things. The log base 2 of 7 times x squared times y. So we're going to take this one log and we're going to split it into 3. Log base 2 of 7 plus a log base 2 of x squared plus a log base 2 of y to the 3rd. Now, that looks really good. We had 3 things that we were taking the log of at the beginning, but we still have exponents. So for the exponent on x, that one's going to come out front. The exponent on 3, that's also going to come out front. So we have a log base 2 of 7 plus 2 log base 2 of x plus 3 log base 2 of y. Let me show you another one where we're using multiple rules. So here we have log base A. We have 5 multiplied by x multiplied by this binomial. So we have 3 things we're multiplying, so we're going to turn that into 3 additions. Log base A of 5 plus log base A of x plus log base A of x minus 1 squared. Now we can't have that exponent, so we're going to take that exponent, we're going to bring it back in front of this last log. So we have 2 multiplied by log A, x minus 1. And I'll show you one more where there's 2 things or more. So here in my numerator, I have 1 thing being divided by a second thing. So we're going to split this into 2 logs. So log base 10 of 10 minus log base 10 of x squared. Now, we can evaluate this log base 10 of 10 because this is saying 10 to what power equals 10. So 10 to the first power. So we're not putting like x is equal to 1. We just are simplifying that to 1 in the same way that if you had like 5 divided by 10, you wouldn't write x equals 1/2. You would just simplify it to 1/2. So when we're evaluating logs, we're not writing x is equal because we're not solving for anything, we're just simplifying. Let me show you how to do that in reverse. So let's say that I have my logs and I want to bring them together. So here I have 3 logs and I have addition. So this is going to turn into multiplication. So it's going to be 1 log base 3, and I have to multiply x times y times 5. And I'm just going to put them in order like I would if this was just an expression. In the second one, the first thing that I notice is that I have coefficients. So this coefficient 2 is going to come up and be on that 5, and this coefficient of 6 is going to come up and become the exponent on x. So we have a log base 4, 5 squared we know is 25, plus a log base 4 of x to the 6. I can see that since I'm adding, I'm going to be multiplying together the 25x to the 6. So log base 4 of 25x to the 6th. In our third example, we have subtraction. So after we move this 4 up as an exponent, then we're going to have to do division. So we have x to the 4th and y. So because I'm subtracting the logs, this turns into division. All right, and then one more. So I check for those coefficients. That's going to come up front. Come up as an exponent. We got lots of them here. I'm going to rewrite it. So I have a log base 10 of 25 plus log base 10 of x to the 6th minus a log base 10 of y to the 8th. Okay, so I need to make sure that I am multiplying this and this together, but then I'm going to divide by that. So we have 25 multiplied by x to the 6th divided by y to the 5th. Now, when you apply your expanding and condensing rules, you do have to make sure that the bases are the same. So in example 4, if the first 2 were base 10 and then the last thing was like base 5, I couldn't use my rules because I'd have different bases. All right, last thing in this video is called the change base formula. The change base formula allows you to take any, so your base goes on the bottom, and this is to be able to take something that's not base 10 and make it base 10. Okay, so you're going from some other base to base 10. Older calculators, or maybe not you know, not a graphing calculator. Some of them don't allow you to put in what base you want. They like only allow you to put in log base 10. So this was kind of super important, you know, not necessarily now, but it's something that you should know how to do, change bases. So here, if I wanted to write this in base 10, this would be a log base 10 of 17 over log base 10 of 6. And what it's asking is it's saying 6 to what power is equal to 17. That's not something that we can do in our head. But then you can put it into your calculator, either using change base, or if you can find the, you know, spot in your calculator. Some calculators give you log and then they give you like a box here to put in a different base. And then you can put what number you want there. Other calculators only allow something that looks like that, where they're only allowed to put in base 10. Okay. And again, remember that when we write our final answer of 1.5812, we're not writing x equals, because we're just simplifying to a single number. All right, so this one's asking us 0.1 raised to what power is equal to 17. If I just wanted to write it in change base, it'd be log base 10 of 17 over log base 10 of 0.1. And again, you should be checking in your calculator and making sure that you can find these buttons and do these things, not just writing down the answer. Ooh, here we have a base of pi. Doesn't matter, doesn't change anything. So we have pi to what power is equal to 400. If we use change base formula, it would say log of 400 it over log of pi. So this 400, this is our A value, so A goes on top, and B is our base, and B goes on the bottom in change base formula. I always like when the base is on the bottom. Helps my brain remember where everything goes. So we did 3 things today. We talked about the properties of logs. What are they? And then we use them to expand or condense expressions. And then we talked about the change base formula.